They're not bad. And y'all got y'all calculators because we can do logs on them calculators pretty quick and easy. So basically, logarithms are just exponents, and it's another way of writing expressions. And basically, all we're going to be doing is finding the exponents. So let me write up here logarithms. The expression log base b of y is used to find exponents. At the base b is raised to for the result y. So the little subscript b is the base or the number that's being hit with the exponents, and y is the result you get from raising b to that exponent. So this expression finds the actual exponent. Okay. Log base b of y equals x. So x will be the exponent. And I'm using a double arrow here. This means if and only if b to the exponent x equals y. So you can rewrite it from a logarithmic to an exponential by taking this base b and raising to that exponent x to get that y. And that's what I've got written over here. Okay. So I'll give you all the idea what these are, and then that calculator knocks all these logarithms out. So let's play with an example on this. And these will just say find the logarithm. Now, I don't know why Mr. Newton went on and called these logarithms instead of, because you're just looking for exponents basically. So log base 5 of 25. So when I see that, here's what this is asking me. It's asking me what exponent do I raise 5 to equal 25. So basically, that's what that's asking me. I see this base 5 here, that result 25. So I am looking for the exponent that you would give to the 5 to make it equal 25. Okay. And that would be a
2, sorry. I'm gonna get it.
A 2 because 5 times 5 is
2. 25, I'm sorry. Yeah.
And then if you wanted to check these, you take that base 5, raise it to the exponent we said, which was 2, and you know 5 squared does equal 25. So they're giving you the base that was hit with the exponent and the answer, and you're finding the exponent that makes that happen. Okay. So we'll say on the calculator. So I'm going to share my screen with y'all online real quick. I got a calculator screen. So to do this on the calculator, you hit the math button on the left side. and you scroll down until you see something that says log base. So let's see on mine, that looks like number A on mine. Once you pull that log base, you hit enter, and it'll bring it onto the screen. And then you see it starts blinking on the place where my 5 is. So you put your 5 in and then hit enter, and then it'll blink on the spot for the 25. I would put my 5 in. Whoops, it didn't like that. Let me see what I did. Okay, then I put in my 25. So once I put in my base 5 and my 25, and I hit enter, it gives me a 2. So it's not bad. That calculator is going to do them all for us. Okay. So what about something like this? Log base 10 of a 10. So basically, what exponent would I raise 10 to make it a 10? So let's see if you're getting it on that calculator.
Yeah.
You get a 1, right? Anything to the first power is itself. So this would basically just be a 1. So you got to go back to some of them exponent rules, okay? So let me play with y'all's memories here. What about log base 7 of a 1? This is where I get most people. But what exponent would I raise 7 to make it equal to 1? Actually, what exponent would I raise any number to make it a 1?
0.
Oh, you spit that out there quick. Remember, anything to the 0 power equals 1, okay? So y'all, here's the thing. If the base matches the result, it's always going to equal 1. If, no matter what base you got here, if that result is a 1, then that exponent is always going to be 0, 100%. Log base 3 of 1 over 81. So y'all, let me refresh y'all. When you get fractions like this, and your number is under a 1, you're going to end up with probably negative exponents. So y'all put that in. Let's see, how many times you got to multiply 3 to get an 81? 3 times 3 is 9.
Negative 4.
Negative 4? I'll see how they do that. So I'll work this one out to see how they're getting that. First of all, I would try to rewrite 81 using a 3. Well, that would be 3 to the 4th, because 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 times itself 4 times would equal 81. Now, what I need to do is try to bring that 3 up to the top. And anytime you move a number from the bottom of a fraction to the top, or from the top to the bottom, you change the sign of that exponent. So this would be log base 3 of 3 to the negative 4. And then that's where I'm getting that negative 4. But y'all ain't gonna figure all that working out. Y'all just gotta be able to punch them on that calculator and spit them out, okay? Let's see what you're gonna do here. How about a log base 5 of 625? That should be a decent size exponent, maybe. Not real big, but
4.
4. Because 5 times 5 is 25. 25 times 5 is 125. And then 125 times 5 is 625. So y'all saying that these are just exponents, right? So here's some things about these. If you see a logarithm that does not have a base right here by it, any log that does not have a base is automatically going to be a log base 10. So y'all see on the left side there's a log button on that calculator?
Mhm.
That's just a log 10, that's just a log base 10, okay? So you can only use that when our base is a 10. Any other base will have to be shown on there, and you have to use the one I showed you in math, okay? Also, we got what we call an LN. And an LN is a special logarithm base E. So those are the only two that are on the front of your calculator. Every other logarithm, you have to use the math button. You go in and use that log base on it, okay? All right, so let me write some more of these examples. How about the LN1? Now, y'all listen to this. You don't have to use the math button to get to this one. There's an LN button right on the front by the 7.
Mhm. I got 0.
0, because remember we said anything raised to the 0 equals 1.
Mhm.
So that'd be just like this problem. Other than instead of being a log 7, it's an LN on that, okay? All right, so this one, let me show y'all how I would put this in there. All right, y'all have a cube root in there also. So to do this problem, I would go down and get that log base first and put in your base of a 5. Then arrow over here. To get this cube root, you hit math again, and it's about the 3rd or 4th choice down will be a radical.
Mhm.
So the 4th one, hit that, and then put your 5 in there and be gone. So you should get a fraction on this. So if it's giving you a point something, 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 get math and enter twice. Anytime you hit math and enter twice, it turns anything back into a fraction. So what you get on that, a 1/3?
Mhm.
And that's because this is a radical, and radicals are written as fractional exponents, okay?
How do you get the cube root?
Hit your math button again. And go down to, number 3. And hit enter on that. And then whatever your number was, go under. So to do the whole problem, do this. Don't get your log base. And then our base was 5. And then go back into math and get that cube root. And then put 5 under that. And then here. Now, we don't want this one, so hit math and enter twice. Now turn them off. So that math enter will always turn anything into a actual fraction for us, okay? The rule, you got a calculator too, I think.
Yeah,
Okay.
I was spaghetti.
So I need to play on mine while I'm doing them, I guess. Get used to them buttons.
Okay.
So I'm showing them where the log stuff is. Hit this math button. And arrow all the way down. And that log base right there, get in it. That brings it on the screen, and then you just put in your, so like this one, you just put in your 5. And then, we'll go back to that, yeah, put 5 there. And then on the big one, put in 6.5. And then enter, and it'll spit out a 4 on that, right? So it's finding exponents. We're finding exponents that these bases can be raised to equal them numbers.
Okay.
All right. So remember, anything that says just log or ln can be done on the front of the calculator. All the other ones that got numbers for the bases got to be done with that log base. Okay. So see what you get on this one. This one is a log 10 to the negative fourth. So that can actually be done on the front also because you don't have a base on it. So you can get the log right on the front by the 7 over there. No, you can use that too. Now, since there's not a base, you have to put a 10 there. And then arrow over and then 10. And then 10, and then exponent, negative 4. So what y'all get?
-4.
Negative 4. And that makes sense. The exponent that I would raise 10 to make 10 to the negative 4 would have to be the negative 4, okay? Whoops. Oh, here's one. How about an ln of an e? Y'all should also have an e on that calculator. Now, I don't want to use the e over here.
Mhm.
I want to use the e by the division sign.
Okay.
So get your ln on the front. So, but don't listen, there's the ln there. You can hit the ln. And then to get the e, you see the little blue e right there? So hit your blue button, and then what's that, divide?
Mhm.
And it'll put your e on there.
Mhm.
So what you get?
1.
Hope you got a 1. Because remember, ln is a base e. ln is a log base e, really.
Okay.
So you got e to the e, and anything that equals itself has to be a
One.
1 for the exponent, okay? All right, so one more for y'all, and then I'll go into switching from one to the other. Log base 23 of a 1. What'd you get on that?
0.
0. And you can always check that with exponents. Put 23 and raise it to the 0 power, you're going to get a 1, okay? And that's one of the rules on exponents is that anything to the 0 power equals 1. So y'all got questions on those ones yet? They're not too bad. All right, so I'm going to go back to this where I had log base x of y equals b if and only if x to the b equals y. Because what they want me to do, I'm going to convert to logarithmic equations. So they're giving me 10 to the 4th equals 10,000. They want me to rewrite it from exponential, which is what this is, into logarithmic. So let's write this. This is exponential because they're writing it with an exponent. This side is logarithmic. And this is one thing we're going to get good at so when we start solving these equations next class, okay? So to write it as a logarithmic equation, I got to have a log written down. The base is the 10. That's what's hit by the exponent, right? So right here, I would have a little base of a 10. The result of raising 10 to the exponent was the 10,000. So your 10,000 would go here. And then the exponent is 4 to 4. Okay, so exponential can be written as logarithmic. The base goes down by the log, the result, and then the exponent is the answer of the logarithmic, okay?
So what was the formula up there?
Oh, this is just how to convert them back and forth.
Okay,
That this is the logarithmic form, and this arrow means if and only if. You can take the base, raise it to the exponent, and get that result as the answer,
okay.
okay? And really, this is how I check those. Okay. So watch this. So let's do a 243 to the 1/5 equals 3. So here we go. We're going to write the log. So the base is the number being hit with the exponent. So my base is going to be the 243. The result of that is the 3. So basically, I'm looking for the exponent that I would raise 243 to make that a 3, and that would be the 1/5. And the only way, and really 1/5, these numbers represent radicals. Actually, let me review y'all on the radical real quick, so you can see how they're getting them fractions. So recall on radicals. So any number that's under a radical, n is the index of the radical, and m is just the exponent hitting that a. This can be written as a to the m divided by n. So that's how they're coming up with these type answers. Those mean these must be hit with radicals. Okay. All right, let's see. Now, you'll have to know how to do this kind of stuff in the next class. And I only got 1 or 2 of them, and they're not bad. You just got to turn them from, they'll give you the numbers, and you got to turn them as a fractional exponent or something. But this is how you're doing it. Okay.
So basically, you just taking those out, factoring it out.
Mhm. All right, we're going to still convert to logs. E to 5 equals R. So once they start thinking you're getting good with numbers, then they're going to start throwing letters at you just to see if you can rewrite them. I know I'm going to write my log. My base. Well, my base is that E, because this is the one getting hit with the exponent. My result is the R, and that's going to equal the exponent of a 5. Now, I'm going to show you another way I could write this. Since this is a log base E exponent, I could just go ln of R equals 5. So y'all watch out, a lot of times if you end up with a log base E, they want you to convert that into the ln. And ln just means natural log. Are any of y'all doing business? So in business classes, you're going to play with that little e a lot in your formulas. And we'll have some, I think it's 9.7, where you actually see the e. And we use it in some of those interest formulas and stuff. Like the exponential graph for COVID, it'd probably be like e to the x. Well, really on COVID, it probably would have started out as 2 to the x. Because it is the 2 minute would be doubling so often. And COVID did double if you watched it, didn't it?
Yeah.
It started out doubling every month or 2, then every month, and then every couple of weeks. And then we was hitting what, 1 to 200,000 a day. So that's the thing about exponentials. If you keep letting them multiply like that, eventually you ain't gonna stop it. It's gonna be chaotic and stuff. That's why we had to put in our mitigation and stuff to slow it down before it kept doubling and doubling and doubling. It was getting pretty crazy as it was already, guys. Oh, it won't do the letters. So anytime you put R in there, it thinks that R equals a number. So let's see what yours thinks. Where's the R at? Right here. So yours actually thinks R is 1.
So that's why we have to put it.
So for yours to do it, these to me are what I call theory type questions. They're really not going to give you numbers. They just want to give you letters to see that you're putting them in the right places when you rewrite it.
So I'll put the, I'll go to the, on there, do 5. Here.
Mhm.
And,
Oh yeah, but this one won't do it because they're hard. We don't know what that thing equals.
okay.
Now, the ones that I say find the logarithms on all those ones, you can use that on every one of those if I can get them all going.
Oh, so you gotta do LN.
Uh-huh. All right, so we're going the other way, and we're going to convert to exponential. So I got log base 5 of 125 equals 3. So now, if you was to put this in log base 5 of 125, you better get a 3 on that, right? So they're giving me the log already. I'm just going to rewrite this as exponential. So I got to find my base. Well, my base is that 5. So I bring down my 5. So remember, that's the base. I raise it to the exponent. Well, the exponent is the 3. So I'm saying 5 to the 3rd is going to equal that result of 125. And when you get done, there's got to be true statements also. But we're right, because 5 times 5 times 5 is 125. Okay. All right, this one has a LN of 52 equals 3.9512. So once again, they're just trying to be tricky, but all we got to do is rewrite it. But LN ain't giving me the base, so we got to know what base is with the LN.
Mhm.
So remember, with the LN, we said the base was the E. Because remember, LN is really a log base E, okay? So E is my base. The exponent is the 3.9512. And that's going to equal that result of a 52. Okay, so base result equals your exponent. Log base M of a T equals -y. Y'all, here's the one thing to watch out on this question when you're doing it. Capital letters got to be written as capital letters in the answers, and in the, what do you call them, lowercase letters got to be written as lowercase in there, okay? If they give you a capital T, you make a little t, it's definitely going to mark those wrong. So my base is the M. My exponent is the -y, and M to the -y has to equal my T. Okay? So I think really what they're trying to do with these problems is get y'all familiar with base, result, exponent stuff, okay? So questions on those ones? So I don't kill you off a lot of these on my test, maybe one or two of these.
Should do more.
Cause you get some of these in the actual equations when we start solving them and stuff, so. All right. Use a calculator to find the common log. We're going to round these 4 decimal places. So if these numbers ain't perfect squares or cubes from them exponents, they're going to give you ever-ending decimals. So they want us to round these 4 places. And now these, you can just use the log on the front of that calculator, okay? So they want you to round to 4 decimal places, the log of 64. Now y'all think about this. This is a log base 10 since it don't have a base on it, okay? Think about the answer here. If it was 10 to the first, 10 to the first equals 10, right? What's 10 squared equal? 10 times 10 would be 100. So, what I want y'all to see this, since this is the base 10, that 64 is in between that 10 and that 100. So that means that exponent has to be in between a 1 and a 2 when you're done. Because if I square the 10, I get 100. That's too big for that, right? So remember, since there's not a base here, that is really a 10. So put that in to see what we get. We better get a 1 point, something.
1.8.
All right, round me out 3 more spots.
0, 6.
0.
0, 6, 1, or 8 if you're on the second.
What's the last number?
It should be
806.
Yeah.
I'm gonna make that a
8.
2.
2.
Oh, 2. Oh, okay, because you round to 1.
Uh-huh.
2.
Yeah. So 4 decimal places. Now if I'd have went one more, that would have been a 7, would have turned into an 8 definitely, right? So just go 4 decimal places and be done with those. So this really ain't a bad day because everything can be done on your calculator. You gotta know a little bit about what it's looking for though, okay? All right, so another one on the front of that calculator, log of 2. Now remember, that's still a base 10 logarithm. And 10 to the first power is 10, but that 2 is lower than a 10, so you're going to get me some kind of number less than 1 probably on this one. So what log 2 gives me? Let's see, that's 20.
3, 0, 1, 2.
Oh, good one, about 400. Oh, there's a
C, D, 3.
3010 is what I'd go with from that.
Okay, 3, 0, 1.
That'd be my 4th spot, and my 5th one would tell me what to do with that 4th spot there, okay? All right, y'all, how about a log of a negative 36? Remember, that's still a base log 10 still, okay? Because there's not a base on it. We automatically assume there's a 10 there. I had 3 people punching. I ain't getting no answer.
1.5563.
Oh, you got a number on that actually? Did you make that a negative 36?
I got an error.
I don't get no number.
Make that a negative 36.
I got an error either way.
Either I did the log base or the log on the front. They both
Yeah, but an error.
Yeah.
So if you get an error, you did it right. That means this does not exist.
Okay.
And I'll explain why. Remember, this is a base 10 right here, right? The logarithm of the base 10.
Mhm.
So I got a 10. So I'm looking for the exponent that I can raise 10 to turn it into a negative 36. I ain't got no exponent that can change just from a positive number to a
Negative.
negative number.
Right.
That's just not happening. So that's why that one says it does not exist, okay? So anytime you take the log of a negative number, guess what? It don't exist.
Okay.
Well, what about an ln of a negative number? Can I do a ln of a negative 1.19?
Nope.
No, that shouldn't, same thing, right?
Mhm.
So this does not exist. So whether it's an ln or a log, if that result is negative, there's no way to turn any base into a
Positive.
negative or positive numbers like that, okay? All right, so I'll actually make this in positive. ln 143.4. And this is just to get y'all good at rounding.
Mm.
So what's that? That should be like a 4 or something.
Yeah, we have 4.9656.
That's what I got wrote down. That looks good, I guess. We're just getting all good at rounding. Now, let me say this. At the end of this section, all y'all's calculators got that long base on
Mhm.
them. At the end of it, it says use change of base. I'll show you what change of base is. This is what people would use if they didn't have the new 984s and stuff, okay?
Oh, okay.
So change of base says to find a log base A of B. For people with the old calculators, they would have to take the log of B and divide by the log A. So it's the log of the result divided by the log of the base. But y'all, if you got 84 or better, you don't have to worry about this, okay? And I'll show you. So this one says use change of base to find log base 6 of 18. Now, I'll do the change of base way, and y'all punch it in there with y'all's log base, and I want to see if we get the same thing. So I'm going to do a log of 18 divided by a log of 6. So that's what we're going to do on here. Oh no, we're going to clear that, clear that, clear that. So do it like I'm going to do log of 18.
Right here.
Log in 18, close parentheses, divide by the log of 6. And then you're going to hit enter and see what we get. So we're getting 1.6131 on that.
1.6139.
So we did it by taking the log of 18 divided by the log of 6. Y'all used the log base and y'all should have got the same exact thing. So if you don't have an 84 or better, that's the way they did it. They don't have that log base in their math feature like we do on the newer ones.
Mhm.
So the older ones had to do it all like that.
Mhm.
But every problem we did earlier, they can do doing that stuff to it, okay? There you go, log base 8 of a 20. So either way you want to hit that. Me, I probably hit math button and go down to that log base and do that. But I know it's going to be in between 1 and 2 because 8 to the first power is 8, 8 to the second power is 64. So it's got to be in between there somewhere. What am I getting, like a 3 point? No, not a 3 point. I'm getting a
1.4406.
1.4406.
06.
And just remember, if these results are bigger than these bases, it's gonna be one or bigger on those, okay? The ones where I had the results smaller than the bases, you ended up with like decimals less than one and stuff on those. All right, so let me just hit y'all with some out of the blue. So what's the log base 5 of 1 equal? You know, anytime you got a 1 there, that's gonna be a 0 every time, okay? What about that next one? Log base, nothing to 10. 1. And remember, that's really a 10 here. And anytime those match, it's always gonna be a 1 for that answer. I remember back in the day, they would do this to us. Log base hard over hard equals 1, as long as that base matches that result. Or they would put snotty faces, you know?
On the first couple of problems of 9-4, it's graphing it.
Oh yeah, but you're just putting them on the calculator.
I know I tried to do that and it's still like, okay, for
No, right, so let's see. There's y equals,
okay, go
do
there.
that. So you're gonna do log x, well, there's my log,
Mm-hmm.
and then put in an x, and then graph. So
Okay,
you're looking for the 1, bam, right there.
okay. I didn't know,
And then-
'cause
and
I think I was doing it.
You probably did it before we learned about the log base especially.
Yeah,
So some of those, actually my number 1 had log base 3 of x.
yeah, I guessed on the number 1, but it was.
You must have guessed
I did, but it was log 2 of it, but yeah, I guess. That one.
And then there's one that should be 1 for the LN on the third one. So you look, most of these graphs will be
Okay,
similar.
yeah, LE, so go to the actual Y equal.
Do that, and then put your LN, and then what you got?
X. What is my X again?
I just use this X right here.
Okay.
Otherwise, you'd have to use that alphabet key and all that.
Right.
So one of them should look like that.
Okay.
Oh, I see.
Okay,
Mhm.
gotcha. Thank you.
So not too bad, just, if any of them have a number with the log base, then you use that other log base in the math.
Oh, okay, okay.
All right, so next class, we'll get into 9.5 and it deals with the properties. So probably for this section, for this test, there's only 4 sections on it. 9.3, 9.4, I mean, 9.5, 9.6, and 9.7. 9.7 is just using formulas like interest and stuff like that, looking at compound interest type formulas. So they're not too bad. 9.5 and 9.6 is the one where we start solving the equations and stuff. So probably next class is really important, learning those properties I'm wanting to show y'all, okay? I think y'all got, what, 2 more weeks of school, then finals. We start finals up. I'll look for sure, but ours will be, what I'll do for ours, finals open up on Wednesday, May, whatever.
If they made a second.
I want to leave for y'all, I'm going to let y'all have either that Wednesday, Thursday, Friday to pick,
Okay,
and I'll just make my final exam due by Friday night or something.
okay.
So that gives y'all 3 days, whichever day you want to play with it and stuff.
So what about the review on there?
Oh, I'm going to try. So here's my plan. We'll be done with 9 stuff next Wednesday.
Mhm.
So after that, all you got to do is that chapter, that last test 4. That next Monday and Tuesday, for y'all, that next Monday is what we call, what's like the last day.
Yeah,
I'm going to review for my final that day,
okay.
but I have a lot of reviews for the final. I'll send y'all and stuff in my YouTube stuff.
Okay.
The final exam is 25 multiple choice questions that will match the 25 questions I do on my study guide.
Mhm.
So
That will match.
Yeah.
Mhm.
the 9-4, is that the one, with the 35 questions?
Mhm.
Okay.
Yeah, yeah, it is.
The one we just did?
Yeah.
Yeah, but there are a lot of them you just punch in and go.
Yeah, it is.
It's got
Those graphics.
quite a few,
on-
but there's only like 5 or 6 where you gotta just punch on the calculator, the graph. And then you're just picking one of the graphs and stuff. But it's got a lot of them like doing log base 2 of 16 and stuff like that. But y'all, every one of them, y'all can punch them right on that calculator. Um, yeah, so that's my plan, getting y'all everything for test 4 by then, in these next 2 weeks. That last day I want to use as a review for the final. So what I'll do is after that last Wednesday class,
Mhm.
or Friday, depending if we need a Friday or not, but we should be good to go. And we actually got a practice study guide for the final online.
Okay.
So I'll get that open with, it might be open, it should be open already online, but
I think it does say review for final or something like that, yeah.
Yeah, the review.
yeah, and that'll show you sort of the questions. I'll go back through that and make sure that's 25 on it. But no, the final is definitely 25, and it matches the ones I did on my study guide. Okay. Ooh, getting close, y'all.
I know. It went by fast. Yeah, I don't know what it is.
It sort of goes slow up until you hit what, spring break, and then it's like boom, after that
It goes fast.
it's gone. All righty, y'all, so I will see y'all Wednesday.